So now you can see the reaction's really going, and it's really exothermic. We're forming aluminium triiodide, and the exotherm is actually heating and starting to sublime off the excess iodine, which you can see coming off as this really nice purple plume.
Iodine is a beautifully coloured element. It has this beautiful purple colour. If you put it in solution, the colour of the solution varies depending what you dissolve it in. If you dissolve it in water, it's a sort of dirty brown colour. If you dissolve it in an organic material like chloroform or carbon tetrachloride, it is a beautiful purple colour.
Iodine is a halide, a halogen element from the far right-hand side of the periodic table, and strongly oxidizing in nature. It likes to nick electrons off other atoms. So what we're going to do is we're going to do a reaction with iodine, and today we've ground some iodine, so it's normally found from chemical suppliers as really nice large crystals. But what we want to do is a reaction with it where we need to make sure that the surface area of the iodine is really, really large, so that all of it can react very, very quickly with the other component.
Iodine also occurs quite widely in nature and is absolutely essential to life. If you don't have iodine, your thyroid gland, which is a small gland that controls development of all sorts of things in your body, doesn't operate properly. Nowadays, iodide is added to table salt in countries like the UK and most other developed countries, so nearly everybody has enough iodine. In the old days, iodine had to be got from the environment, and usually from the spray from the sea that was blown across the land. And so in Nottingham, which is really near the centre of England, a long way from the sea, or relatively long way from the sea, there were serious illnesses caused by people not having enough iodine, so-called goiter, which caused a swelling. The thyroid gland gets bigger, and this used to be called Derbyshire neck, this unpleasant illness, because it happened in this area of Nottingham and Derbyshire.
So what we're going to do is we're going to mix it now with another element, and that element is aluminium. So aluminium has electrons to give away. Iodine's going to nab them. You're going to see some oxidation chemistry and the formation of a new compound, which is aluminium triiodide. It's a really nice chemical reaction. But the way that we do it is we mix the two together, and then we have to add water, which acts a bit like a solvent, but also the oxygen in the water activates the iodine so that it becomes more strongly oxidizing, and then hopefully we'll see the new reaction. So I'm just going to put some out into this small vessel.
You can see this development effect of iodine really well, that if you have tadpoles, baby frogs, they don't develop their legs and turn into frogs unless there is iodine in the water.
The other component in this reaction is aluminium, okay? And we're using very, very finely powdered aluminium, not foil or not a rather large lump. This has been specially powdered for us, so again it has a very, very high surface area.
One of my favourite chemical equations is tadpoles plus iodine goes to frogs.
So you can see the aluminium and the iodine mixed within this solid mixture. Now still, these two components, these two elements, they're still held away from one another. They can't react. So what we need to do is add a small amount of water, which acts a bit like a solvent, but it also activates the iodine, and then we'll wait and see what happens with the chemical reaction.
Iodine can be used as a disinfectant. In fact, chlorine can be as well, but solution of iodine is often used when people have cuts. So if you cut yourself, unfortunately I haven't any cuts at the moment, you can paint on iodine, and because of its rather red colour, it made cuts often look much worse. Children would come home from school and their whole hand would be red, and this would cause some excitement at home. But it is quite an effective antiseptic. Water?
Just take a small amount and add it to the reaction. So you can see it's starting to go now, the chemical reaction, because we're seeing the excess iodine subliming and forming a vapour. Now if we go in close, we can hear it fizzing, because this is actually the oxidation reaction and the formation of the new aluminium triiodide. Now, I'm going to just mix this slightly to try and increase the rate of the chemical reaction slightly. So now you can see the reaction is really going, and it's really exothermic. we're forming aluminium triiodide, and the exotherm is actually heating and starting to sublime off the excess iodine, which you can see coming off as this really nice purple plume. Now deep inside the reaction now you can see the exothermic, or the energy coming out and starting to cause a flame. Really, really nice, very, very rapid chemical reaction. Really beautiful. So we're forming aluminium triiodide here, which again is a very, very delicate compound, quite reactive in itself. But you can see now the really nice new crystalline material. So, sadly, we've managed to stain the Stig's fume cupboard. All of this really nice iodine forming a very fine layer across this fume hood.
What do you think about that?